Good morning. Good morning to everyone. Guys, good morning. Today we're having Dr. Nirmal Kishnani. He's Associate Professor of Architecture in the School of Design and Environment at the University of Singapore, National University of Singapore. He's also Program Director of the Master of Science in Integrated Sustainable Design at the National University of Singapore. He is Chief Editor of the Future Arc Journal, which focuses on green architecture in Asia, and resident jury chair of the Future Arc Prize and the Future Arc Green Leadership Award that helped to establish. Nirmal Kishnani was Vice Dean of the School of Design and Environment at NUS from 2004 to 2017 and has been for many years visiting professor at the University of Navarra in Spain here. He also lectured and conducted workshops on green design processes in Australia and Asia. He established one of Asia's first consultancies dedicated to greening in 2002. His team advised developers and project teams across Asia, including landmark developments such as the Asian Development Bank retrofit in Manila, the Islamabad Airport in Pakistan, and the Gardens by the Bay in Singapore. His areas of interest are environmental psychology, climate, comfort and consumption, and sustainable buildings. His research interests include high-rise buildings in the tropics that strive to create indoor comfort via passive, active, and mixed mode strategies. As well, he's author of the book titled Greening Asia: Emerging Principles for Sustainable Architecture. Please welcome him with an applause.
Hey, good morning, everyone. Thank you all for coming. I'm very happy to be back in Pamplona. I should tell you my jet lag is kicking in right now, so everything is starting to get a bit blurred. I've been very busy the last 4 years with two things. One is this building, which is the new building at the School of Design and Environment. We have just opened it in January. I showed this 2 years ago when I came to give a lecture here, but back then, 2 years ago, it was still under construction. So I get to share with you for the first time some of the new images and the story of this building. The second thing that I've been really busy with is my new book on designing ecologically in Asia. Now, this book is not finished yet, but I have made a video for this book, and today I'm going to share with you this video. You are the first to see it, and I will be happy to discuss with you your opinions at the end. We will probably release the book and the video in April or May. So the video that I will show you later is not complete. There are many things missing, but it's okay. I figured it would be interesting to test it with an audience. So I seek your patience, because after talking for a bit, I will switch on the video, and the video is 40 minutes long. So I was joking with Juan Carlos that 40 minutes is a big risk with the architectural millennials, because you are not used to anything longer than 5 minutes on internet. So why am I making a 40-minute video? I don't know, but it's such an interesting story for me to tell that I felt that 5 minutes was just not possible. It needed, like a good wine, you have to sip it slowly. Anyway, we'll discuss that later. Let me start by sharing with you the project that I've been involved in. This is the new building for the School of Design and Environment. It's called the new Net Zero Energy Building, SDE4. SDE4 because we have 3 buildings, SDE 1, 2, 3, and this was the 4th one. I was involved very closely with this We had consultants who were designing the building, and we had engineers and architects working on it. My job was to manage the process. So I was the client from hell, meaning I was making sure that the project team did not lose sight of the objectives of the building. And the big objective of the building was that it should be net zero energy. Now, the definition of net zero energy is quite simple. The building must produce the energy that it needs on site. Everything that is needed by the building in the course of 1 year must be produced on site. It is still connected to the grid, so it puts energy into the grid and it takes energy out of the grid. But when you add up over the course of 1 year how much it puts in and how much it takes out, it cannot be positive. It must be zero or less. So that is the definition of net zero. There are not many net zero buildings in Asia. There is one other building in Singapore which is net zero. But that building was a retrofit. This was the first new building that was aiming to be net zero. Now, if you know the tropical climate, you will know that a big part of the problem with the tropical climate is creating conditions of comfort. In fact, more than 60% of energy used by buildings in the tropics, at least in Singapore, in Southeast Asia, goes to air conditioning. So the challenge with this project was how to create comfort without using excessive amounts of energy. But the second question was, how do we create the energy on site? What technology do we have, and how do we integrate that technology into the architecture of the project? I have to say I'm very proud of this, not because it's net zero. I think that's a nice thing, but because we were able to achieve something quite remarkable from an architectural standpoint. I will show you more images as we go along, but here, just to give you context, this is the university campus, the National University of Singapore on the west of Singapore. And there in blue is the School of Design and Environment, and the red block is the new building that we have created. Now, I like to joke that nothing frightens a school of architecture more than to ask them to make their own building, because everything that we teach must be in the building, no? It must represent all our aspirations. So when the project started, it was very stressful because we had to pack a lot into this project. It had to do many things at many levels. And I think this is what made it so complex, because we wanted it to be zero energy, but we also wanted it to be beautiful and to be comfortable and to be inclusive and to be biophilic. All of these things that we teach in the School of Architecture, we needed to represent in this project. So here is a very quick summary. It's not a very big building. It's about 8,500 square meters and on 6 levels, and most of it is architectural studios, design studios, laboratories, some classrooms, and a lot of social space. Yeah. I hope you will bear with me, because I have a short video, and sometimes I think it's better to see it in video than me just talking about it with images. So I will run a very short video on the completion of the building. This was used when we launched the project in where is it? Was it Google Chrome? Here we go.
I think as an academic institution, and particularly in the School of Design Environment, it is really incumbent on us to walk the talk. We need to continuously position ourselves in advance of the current state. That's our mission as an institution, is to continue to push the frontier to research and development of even higher ideals and higher aspirations.
In the campus master plans completed in 2008 and 2012, the then President Tan Chong decided that each faculty should have a new flagship building that will inspire the occupants to continue to excel in teaching and research activities in an increasingly competitive academic landscape.
We needed a building that would encapsulate the challenges of our time. Sustainability had become an important part of what we teach. The architecture of the school needed to match the pedagogy of the school. This was done right. It would not only add credibility to what we teach, it would allow the use of the building as a teaching aid and research scaffold.
The values of SD4 are twofold. One, for SD itself as an educational institution, is really to set a precedent, aspiration for all of our students in terms of performance, but also architectural formal clarity. This sets a tone in which we as educators teach our students, and it becomes a way of showing immediately to our students the values that we have as a school.
First of all, having a building looks very tropical. I think it will make a very handsome entrance building to the university. And all this will achieve with good architecture without compromising the sense of space, the beautiful proportions, the combination, the articulation of the materials, the details.
Different spaces has a certain informality and the generosity that the spaces provide. So there's a lot of breakout space, interpenetration of workspace, as well as collaborative space, learning space, and research space, so that it cultivates a sense of collaborative work or collaborative learning within students.
The veracity of this partie, I think, is pretty fantastic. The south elevation, it's framed by a colonnade that supports the large PV panel above, and in a way it really speaks to the kind of amazing integration between the natural environment, the outdoor climate, and interior spaces.
This project has preserved a sense of lightness and space, and interestingly, this ambiguity between the indoor and outdoor space was even visible during construction. For example, in the way in which the building structure and scaffolding encapsulated the existing trees.
In architecture, the building is as good as, of course, the client as well as good as the architect. So both has to be pushed by the brief, and in which the vision was very, very clear. There's a vision to look at environmental performance, environmental sustainability in a very, very serious way. So I think the coupling of a vision, clear vision, and the technical performance that we have here really paved the way and guided our architectural response in a very, very productive way.
This building is going to be very different than the rest of the building in NUS. Different type of mechanical system, this is ceiling fan, and the way the building operates will be very different. We will have a lot of training, we have to engage a lot of training to the users to teach them, educate them how to use the systems or to use the building.
SD4, in fact, being a net zero energy building, is attracting a lot of attention. It's a showcase of NUS. After the project completed, a lot of these agencies or other institutions would like to learn from NUS how we really achieve a net zero energy building.
To design a net zero energy building is something which is particularly interesting for me, but in particular for Singapore and for the School of Design, I think it's key. There's a generation of students going through this school in the next 25 years, and this is the place where we will learn.
If this building can teach just a small group of people how to sort of help out in the environmental aspect, and then they disseminate down to the people at large, back in home, back to society. I think then SD4 is a fantastic building to start with.
I think it also reflects what we have learned as a team along the way. I think one of the key learning points would be that of sharing knowledge and developing a pragmatic understanding of design principles, systems across disciplines.
But the project went even beyond this target, looking at opportunities for pedagogy. And this whole idea of integrating design, construction, teaching, and research was translated, for example, in seminars, in workshops and site visits with SDE students and staff, but even in signing a memorandum of understanding with SDE partners, in introductory sessions with delegations and embassies, and the entire process became pedagogical. All this was a very clear and important message, particularly for our School of Design and Environment.
That's why we are doing what we're doing, so that the students get the opportunity to experience firsthand what it is like, first of all, to engage in such a process, to design, develop, construct, and operate a state-of-the-art building that is supporting of well and green, but at the same time, they themselves also must be influenced to adapt their own behavior in living inside such a building.
I apologize for the PR. It sounds like I think I'll get the video. Sorry. I think it's running. That has nothing to do with the new building. Yeah, I mean, the video was produced as a way of promoting the ideas of the school to audiences. So let me take you through step by step how we got to this project, and it was a very difficult process, and it was not. Of course, when you finish a project, you explain it like it was natural. Of course, we're going to make a net zero building because we are a school, but actually it took a long time. It took a very long time, and it was very hard work. And the biggest challenge was really of redefining comfort and redefining how we function as a school of design. So let me take a little bit of time to walk you through step by step how we got there. Yeah, the thinking. So the problem of the tropics, I should say the challenge of the tropics, is that we now have become addicted to air conditioning. It's not that we cannot function without air conditioning, but as a matter of lifestyle choice, we have become so used to it that we don't know how to imagine a world without it. I mean, this is a photograph of a beautiful old historical district in Singapore, which if you come to Singapore, you must visit. Because it's so charming, you know, it's like a precinct of old shop houses. But when you walk in the back alley of these shop houses, you see nothing but air conditioning compressors, you know, and these compressors are all rejecting heat into the space, and so the environment heats up because of all this technology. So it's not a good thing that we're doing, yeah. And so the idea was very simple, and it begins with the question of how does architectural form address the climate. These are images, by the way, that were submitted by the architects at the design competition. So this really was how it was imagined. Yeah. Very often in projects, when the project is finished, the architect will tell a story that is different from how it began. But this is really the core thinking. And so they argued that the base case of the building is that it must have the right orientation, but then it cannot be a compact solid object which then internalizes all its air conditioning systems. It needed porosity. And so the architectural language that they proposed was that of platforms and boxes. And so the way that the building would function is the way that it looks, which is you have these floors, and within that you have these boxes, and you have these gaps between these boxes through which air flows. And this logic was there from the beginning, and it kind of stayed there. And Chris, who you saw in the video, he's an excellent designer. I have great respect for him. He was able to hold on to this ideal. Yeah. And the basic premise is this, that you can air condition where it's needed. But in the spaces where it's not absolutely needed, perhaps air conditioning is not the answer. And so the building is designed as a mix of spaces, those that are climate controlled and those that are naturally ventilated and porous and connected to the outdoors. Here is an example of the space, the studio. And one of the things that we decided as a school when I was the vice dean was that we would switch off the air conditioning at 6 o'clock. A bit draconian, like, okay, now the aircon goes off, open the windows and switch on the fans. You know, you don't have a choice. This is something that we will have to communicate to the student body, and we have to educate them on why this is necessary. Because I think when people believe in what the bigger idea of what you're trying to do, then they are prepared psychologically to accept certain levels of discomfort, or they're prepared to accept alternative modes of comfort, meaning they don't demand air conditioning all the time. So right now, Giovanni, the guy who was talking in the video as well, his job is to teach the students how to use the building, but not just as a rules, but to guide them on what the building is trying to do, to persuade them that this is something bigger than just everyday architecture. Yeah? Here are some of the spaces that Chris was talking about, where there is a very strong biophilic element to this, where the inside and the outside are deeply connected by lines of sight and movement. And so the architecture kind of began with the idea of a fragmented form. Too often in the tropics, we try to create buildings that are very compact. And the compactness that we instill in our architecture has a lot to do with the efficiency of air conditioning systems. Because the more fragmented the form of the building, the greater the exchange between inside and outside. So that leads us to a certain kind of architecture. But what we decided very early on is that we were going to challenge that. We were going to not fully air condition the building, but also we were going to fragment the form. And by fragmenting it, we were able to free the space for natural ventilation and for social space. So the community intention, the idea that a building like this is not simply functional spaces, but it is also spaces where we socially interact with each other, became very early at the beginning. Yeah. Here are examples of some of those social spaces. You don't see any people because it was because like a lot of architecture, we wait for people to leave the building before we take photographs for some reason. I don't know why. But the idea is that these spaces are meant to be inhabited by people. Our students are meant to hang out in. And they are very beautiful, very comfortable spaces. This tree, by the way, we fought very hard to protect. If you imagine that this tree is surrounded by foundations and a basement structure, you begin to understand how difficult it was to hold on to one tree. And they had to build a scaffold, what Giovanni was talking about. They had to build a scaffold to wrap around the tree so that they can do the construction around it. But these are the kinds of spaces that the students will enjoy. These are spill-out spaces from studio where they can go out and they can have their meals, or they can use these spaces for some of the more messy work that architects do, like spraying and so on. Yeah. And then the second layer of thinking, of space making, was the space that would create opportunities for learning and research. And we knew very early on that the building shouldn't just be an object, it should be a scaffold. Which is to say that you should be able to take away things from it and add things to it. So here you see, for example, a part of the facade that is meant to be removed. Yeah. And if you are a researcher in the building, if you are working with the School of Design and Environment and you want to study, say, solar panels, the new technology, or you want to study green facade systems, you can simply take off a part of the wall and attach your research elements there, and you can get data. So the idea of a living laboratory was also there from the beginning. It was part of the vision statement that we need to have spaces that teach us not just what to do now, but what to do in the future. And these spaces also begin to behave socially. So all the corridors and the staircases are exaggerated. They're not just for circulation, but they're also spaces for students to hang out and to interact with each other. The idea of a climatic response found its way in the shape of the roof, and the roof began to act as a canopy that would define the performance of the building. Here are some of the early studies that were done on the facade of the building. This was before we extended the roof. And you can see that the language of solids and voids creates a highly differentiated facade system in terms of solar exposure. This was again submitted in the beginning during the competition, where the architects were already looking at the idea of shielding the facade from direct solar radiation and relying on diffuse light. I want to point out the image on the right that was proposed by the architect at the beginning, and it looks like something, you know, Le Corbusier would design. It's so minimalist, it's so clean. The final thing was very different. It kind of goes through a process where you begin with this kind of idealistic image of what architecture is, no indentation, nothing. And then as you go along and you learn from performance modeling, it begins to change, it transforms itself. Here are the south and north facades showing you what that exposure looks like. And then, of course, we had to protect the east and west facades, and this is made up of the solar screens that protect the more exposed facades from sunlight. So as I said, in the tropics, the big problem is that we consume a lot of energy due to air conditioning. And this we knew would be a problem. Now, just to give you a perspective, if this building had solar PV on the roof and it was designed as a conventional air-conditioned building, this is how big the roof would have to be. So the blue shows you what the size of the solar PV would have to be to make it a net zero building with conventional approach. Yeah. And so we began with this absurd drawing, which of course is not buildable. But what it told us from the start is that we had to incrementally chip away at the demand of the building. We had to look at how much energy the building needed. And our consultant, Wolfgang, who was in the video from Transolar, he guided us through a series of steps, and he said, okay, so here we have the reference building. What if we improve the envelope and we reduce the solar exposure? What happens to that? And here are some of the designs produced by Transolar, the company, in terms of what that looks like in detail, both in terms of shading elements and lamellas to bring the diffuse light in. Here are some of the studies that they did during the design process. It was a very, very intense design process where we looked at many, many iterations and options. And here, for example, they showed us for different facade systems, if you have different overhangs, different types of shading options, different glass properties, what would be the cooling demand resulting from that? So they produce a matrix, iterative study looking at all these different options. And so green is good, red is bad, yeah, just to give you a quick idea of that. And from this, we began to select both the extent of the overhangs, but also the type of glass and the composition of the facade. And so from an initial 100% energy scenario, we found that by using strategic shading systems and glass selection, we were able to reduce that by 25%. Still an absurd building. Too big, the roof. We had to find other ways to change it. Just to give you an idea, this is what it looked like at the beginning when they won the competition, and this is what it looked like a few weeks ago when it was completed. I think it's better. I think it makes it more interesting that the facade tells the story of the climate. That when you look at elements of the facade like these fins and these lamellas, you begin to understand what the building is doing. Here I mean that the form and the vocabulary of the building is beginning to talk about where it is in the world. I'm not sure that this necessarily says tropical. Yeah. Chris is a really good architect, but he began the process with a rather, shall we say, a temperate idea in his mind, a very kind of almost like a Corbusian idea of planes and clear full height glass systems, and that had to be changed. And I think to his credit, every time we began to do these performance studies, he began to incorporate it into his thinking, and the architecture became more interesting, not less interesting. He didn't see it as a compromise, he saw it as a way of deepening the connection between building and place. So this is what we got at the end. And then we said, okay, 75% still too much. What else can we do? We studied the possibility of using very efficient air conditioning systems. But the other possibility, which was even deeper than just efficiency of chillers, was what was called the hybrid cooling system. The hybrid cooling system works like this. Instead of having fully cooled space with 23 degrees set points, the cool air that is supplied to this is tempered, meaning it's not highly cooled. It brings the temperature, the air temperature, to 27, 26 degrees centigrade. This is combined with ceiling fans. And ceiling fans provide air speeds of between 0.5 to 1 meters per second. And there is a grid of ceiling fans over the entire space. And so the combination of air movement and cool air provides an operative condition, which is to say the thermal sensation you have of about 24, 25 degrees. So you know, the theory of thermal comfort is that there are all these variables that go into affecting your sensation, not just air temperature, but humidity and air movement, etc. Also what you wear, yeah. And so the idea was that we shouldn't burden the air temperature, because that is where all the energy goes. Because if you make the building work very hard to create 22, 23 degrees centigrade, then you're consuming a lot of energy. But if you reduce the demand on cooling, but instead compensate it with elevated airspeed, a fan costs a fraction of the energy cost. And these fans are really literally working on very minimal energy. I think a few watts was the efficiency of the fans. Now this idea that we don't necessarily need full climate control, that we actually want to interact with the building and control our climate, is referred to as the adaptive system, adaptive cooling. And this has emerged in the literature. I mean, it's been around for a long time. Yeah. The idea of adaptive cooling was discussed in the 80s and 90s in the theory of thermal comfort. But we began to see interest in this as we explored the reliance on air conditioning. And the thinking is that if you take away full reliance on air conditioning and you combine it with ceiling fans, people can actually get up and adjust the fan speed where they are. So you can regulate your comfort at a local level. Whereas an air conditioning like this space gives you cooling all the way through, front to back, it's the same thing. In theory, yeah, it should be the same. But with adaptive cooling, a large volume space like this has higher temperatures but a grid of ceiling fans. And it becomes possible for the person at the back to turn the fan up and the person in front to turn it down. And this creates differential conditions. Yeah. And it makes sense. It makes sense because we don't all want the same thing all the time. And in large spaces like our studios, they're not occupied all the time. Sometimes there's a group of students working here, but the rest of the studio is empty. So it allows the architecture to deal with the variance of human loads and the difference of human expectations. So with that hybrid cooling system, we were able to bring the energy demand down to 50% of the base case. Still too big, yeah. So the question was, what else can we do? Here is Chris's drawing at the competition stage. This is what I mean about Le Corbusier. He's got this kind of hyper-modern, minimalist idea of what the interior would look like. And this is what it eventually looked like. Again, I think it's better. For me, it feels like you're in a tropical condition. Yeah? You feel that the envelope is doing something, the fans and the ceilings are doing something, as opposed to this kind of raw minimalism. Anyway, the second thing that we targeted was the question of human consumption, meaning to say, what kind of laptop do you use? You know, what kind of printers do we have in that? So the rule, and this is where it becomes a question of managing behavior, because it's not just about what the building does, but what we bring into the building, right? The rule was that we would all be using very efficient equipment. Nobody was allowed to charge their phones, for example. You do that at home. But printers, copiers, laptops, no desktops, everybody has to work with plug loads that are as low as possible. And that, we found, brought it down to 25%. Now the roof fit the building. Yeah. Wolfgang was very good because he started by saying to us, he said, if you want a zero energy building, it's very simple. You calculate the size of the roof, you calculate how much energy that produces, and that is your budget. It's like having a financial budget. It's like saying, I have $12 million. That's how much money you have. It's a question of how you use that money, right? Same principle applies to energy. He would say, this is the size of roof you have, this is how much energy you have. Now, what do you want to do with it? And so all of these steps that we went through were really about looking at how do we use that energy? How do we trim the things that we don't need? Separating the question of what we need from what we want. Yeah? This was a big part of that discussion. Then, of course, came here is another quick image of the interior. And the final thing that came into the picture was the solar PV. And we were very lucky because the cost of solar PV, while we were deciding how this building would be designed, came down to a point where it became more affordable. Yeah. And also, we were able to get the highest efficiency products available on the market today. And that went into the roof of the building. I like to tell the story of how people think that the building began with this big roof. Actually, it did not. In the beginning, the roof was the same size as the building. There was no cantilever. There was no overhang. But we tried and tried and tried, and we could not get to zero. So then we had to make a decision. Either we make the roof bigger to accommodate our energy needs, or we put solar energy on the facade. Now you can put solar PVs on the facade, but 1 square meter on the roof produces the same amount of energy as 5 square meters on the facade, because you get less energy out of the facade. No, its orientation and the exposure is limited, so it's a 1:5 ratio. So if we decided to put solar PV on the facade, we would need a lot more solar PV. In the end, and this is a cost calculation, it was cheaper to build a bigger roof. Now I have to give Chris credit, because many architects would say, oh no, this is so different from what I started designing with. They would fight it. But he was able, with the colonnade, to create an architectural expression that felt almost natural. When you look at the building and you see that big canopy roof with the promenade in front of it, it feels very tropical, it feels very natural. And so the architecture evolved as we went through the process. Of course, the key to this is that you have to plug into the grid, because solar energy is volatile. There are days when you have too much and there are days when you have too little. And so you rely on the grid of there's a microgrid at the university, and sometimes you put in the extra, sometimes you take out the deficit. Yeah. And that's how we arrived at the zero. I think one of the most important things about the project was the process. And I can't emphasize this enough, because we tend to believe that if we just have the right strategy or the right technology, we can get to zero easily. But the experience on this project was that the project team, the architects, the engineers, the quantity surveyors, the project managers, everybody that was involved in the project had to relearn what they knew or thought they knew. Yeah. And we went through a very, very difficult design process. And the design process was one in which we had to break down our assumptions. Because I'm not sure how many of you are practicing architects or have been in practice before, but when you begin a project, the engineer will say to you, okay, give me the drawings, give me the floor plans, and then they will go and put the air conditioning systems over it, and they will buy the air conditioning systems based on what's available in the market, so it becomes a kind of a collage thing. You couldn't do that. We had to rethink it fundamentally. I mean, the hybrid cooling system would not have emerged if we had to do it in the usual way, because nobody would have arrived at that. We would have all gone to look at brochures and say, here is an efficient chiller, or here is an efficient air handling system. We had to go back to fundamental principles. And that is painful. Painful, especially if you've been in practice for a while. Yeah. And painful also because you really feel very vulnerable, very exposed. Meaning to say, as an architect, as an engineer, you have to be open to what other people think of what you're doing. Yeah, it makes you feel very insecure, because an engineer can say to an architect, your idea is terrible. It doesn't work. There was one time, I remember Chris had a proposal for a super expensive glass system with a mesh inside. And he said, this is going to reduce the energy by 40%. And the engineer said, no, it's not. And it was like really painful. It was hard to have these conversations, because we have so much pride in what we do, so much faith in what we've learned, that we had to let go of a lot of these things. So what should have been a 2-year process took 3 years. Yeah, actually, I should say the design process should have been 1 year long, but it took 2 years. Yeah. And during that process, we went through a whole series of iterative charrettes. Now, a charrette is basically a meeting, like a project meeting, where everybody involved in the project comes together. And we sit around a table, 50 of us, discussing ideas, evaluating solutions, and developing criteria, and looking at how far we are from the target that we set ourselves. So it was not easy, yeah. It was not easy to do that, but it was so necessary, because without this kind of consensus, without this investment of our professional pride, it was impossible to do this. Everybody was pulling in the opposite direction. So my feeling is that the hardest thing about high performance buildings is people. People get in the way of making green or sustainable architecture. And we have to retrain the human element. We have to teach architects and engineers new ways of thinking and working together. Because without that, all the technology and all the ideas in the world will not get you very far. I want to summarize the story of this building by showing you a little bit of the big picture. Yeah. So in the discussion today, we are talking about this trajectory. That is to say, we are moving from negative impact, which really is buildings that are code compliant, yeah, and they represent conventional practice. We're moving towards what we call less negative impact. And here we see a lot of green buildings in the world. Now, green defined in a very limited way. For example, LEED certified is green. Yeah. In Singapore, we have Green Mark, which is a green certification system like LEED. And so when we talk about green, we typically mean that this building is less negative than a conventional building. it's not zero impact, it's just less bad. Now we are, of course, talking about zero impact. And the idea of sustainability is that we can actually reduce our impact to the minimal or to zero. Now, the SDE building that I showed you, it doesn't do everything, but in terms of energy, it is zero. Yeah. So here we begin to discuss what that zero looks like. If we want to get to zero, what are the things we need to do, and what does that do to architecture? How does it transform architectural thinking? Yeah. But I think that's not enough. I think that if we look at where we are in terms of environmental degradation or climate change, it's no longer enough to just be zero. We have to look for something more than that. And this is the topic of my book. Buildings that are regenerative, buildings that are net positive. I'm exploring this idea in the Asian context, but it's not limited to Asia. There are many, many places in the world where the same discussion is taking place, which is how do we make buildings not just do less harm, but to do good? What is good? What do we define by good? How do we measure good? In what ways do we bring goodness back into our architecture in our cities? As a famous architectural historian, Peter Buchanan, and he said that the big critique of sustainability is its failure to describe what constitutes the good life. Sustainability is not just the objective and the technical, it must include the cultural, how we reconnect with self, others, and the planet. So the problem that we've had in the discussion on sustainability is that we're always talking about how to do less harm. But at some point, if we are going to persuade millions of people around the world to become sustainable, we also have to describe a better life. We have to describe a better way of doing things, not just a less worse way of doing things. I think it's a very important subject of how we repair cities. I think it's one thing to talk about green and sustainable as an act of mitigation, of doing less harm. But we have to find a way to go beyond that. And we have to find a way to bring nature into the discussion. Because until we begin to realize that the real problem is not the efficiency of the building or LEED certification or whether we have a green label, the real problem is that we are disconnected from nature. We have found a way to design as if we are separate from nature, and that's not going to work in the long term. So, any thoughts, any questions, any comments? Yes, please.
First of all, thanks a lot for the talk. Really good. And secondly, I know that it's a very tricky question, it's difficult, but you say something about climate change before. So, how do you feel that cities need to adapt themselves to the future within the different climate change scenarios that we know that maybe are happening in the future?
Yeah. I think the discussions that are taking place now are partly about how we reduce greenhouse gas emissions, but they're also partly about how we cope with climate change. So the references that were made by Yu Kongjian, the Chinese landscape architect from Turenscape, about cities in China being sponge cities, is a direct reference to how extreme weather in these cities is causing a lot of damage, seasonal damage. And the idea of a sponge city is one that can absorb the water, the extreme weather condition, and it can cope with these fluctuations, these variances that are coming about. There are also, many of the projects also are really looking at ways of mitigating the impact of heat in these cities. Kampong Admiralty, the project in Waiwoha, or even the parks that have been shown through the project. They are really building the resilience of the city. So I guess the core argument is that many designers and planners are beginning to look at not just how to reduce greenhouse gas emissions, but also how to prepare for a different condition, a different kind of an environmental condition that's coming. I also think that that a lot of what we discuss needs to look at the broad spectrum of issues. So it's difficult to talk about climate change to someone living in a slum in India. You know, it's their idea of survival is not what happens in 20 years, but it's what happens tomorrow. Yeah. So I think the challenge of Asia is that you have to find a way of managing this conversation both for people who have wealth and who are likely to contribute to climate change versus people who are struggling to survive, who are bearing the brunt of climate change, and for whom social and economic issues are on the front of discussion. So in a way, it's you have to deal with the problem, but the way you enter the problem becomes different. But thank you for that. Anyone else? Yes, please.
The moments of the speech, you talk about like all the houses and all the apartments with all these air-conditioned machines. Is anyone doing anything with all these old buildings and this kind of stuff, or just building new zero net consuming buildings?
Okay. So correct me if I'm wrong, but you're asking whether things like hybrid cooling systems can apply to existing buildings. Is that? Yeah, absolutely. What I didn't show in my lecture is that we are now working on retrofit of our existing buildings. So we finished the new building, but we have 3 existing buildings that we are retrofitting. And these existing buildings will have the same hybrid systems. So we are adapting the systems to existing buildings as well. It's unlikely that the retrofit will result in zero energy. When you are dealing with an existing building, it's harder to have very high performance, the same performance as a new building. But we think it can be a very, very low energy building, but it will have the same systems. So yeah, that will be the next video. We will finish the retrofit probably in 3 years, 2.5, 3 years. Yes?
You said that one of the methods used to reduce the energy of the roof was to retrain people to use different methods of plugins and plug-ins. So how was that an issue with the people? How did people reacted, or students reacted to that response on the environment they developed? That's a really good question, because I don't have an answer for that. We just to give you an idea of the timeline, we have just finished the building, so it was occupied in January, and at the moment it is not 100% occupied, it's semi-occupied. We're about 50% capacity. In August, we will have full capacity. And I like to say that the real challenge is when the building is running full capacity, because we really have to be involved in training the students to use the building correctly. But also, they have to change their habits, and they have to not bring their laptops and their computers to charge in the university. All of these things have to be taught to them. The additional problem for us is that every year we have new students. So it's not like an office building where you train people and they learn and then that's finished. Every year you have to keep repeating it. You have to keep teaching new students how to manage the building. So I think the answer is an ongoing one. We have a lot of programs in place. We have seminars and teaching sessions with students to guide them on what are the do's and don'ts of this building. But I want to say that we don't make it sound like a whole bunch of rules. I think what we try to do in the training is to persuade them that this is an exciting thing, this is a good thing. You know, like sometimes we think that sustainability is giving up stuff. You know, we have to give up this and we have to give up that. We want them to be excited by the project, to see it as a positive thing, that it's comfortable, it's healthy, it's giving you a lot of good things, yeah. And then you don't feel so bad when the air conditioning switches off at 6 o'clock, you know. The psychology is important, because I think very often the sustainability movement is painted as a very pessimistic thing, that you have to give up so much. But I think that project is an example of what you gain as well. Anybody else? Yes, please.
Hello. First, I want to congratulate you for the presentation. It's amazing. The work you did with your team in Singapore is incredible. The building is really amazing. I want to just one reflection about that, because I think we must to involve more with the people we work and the user of the building. I think is the key, a big challenge for us. And I think we have to must think involve the weather in our projects and make or try to make more things in our scales. Not all of us can we make that kind of projects, a huge project, but maybe we have to must to think how we can change a little bit to join that effort to make better things, like you say. And thank you for the experience.
Oh, thank you. I have to say, I think that the hardest thing is changing people's minds. This is really challenging. It's very difficult. It's more difficult than doing simulations or doing calculations. The human element is very difficult. But I tell you a funny story about this, because when we were finishing the design process, about 1.5 years after we began, at one of the discussions, somebody said, oh, you know, we should do the ducts like this, blah, blah, blah. And they were discussing the system, the hybrid system. And the air conditioner, the engineer, he put up his hand and he said, oh, but that is really ugly. You can't put the ducts like that, it will spoil the appearance of the space. And I remember thinking, this is amazing. You know, because usually the architect is the one who makes noise about aesthetics. But if the engineer feels like he or she has a stake in this, and they begin to get involved and they begin to have an opinion, not just on the quantitative performance, but also the emotional, the visual aesthetic performance, then I think you've made an achievement. Then you've changed the culture. That's what I think. It's a nice building, but I think the biggest accomplishment is the people, to change the way people work. Last one, anyone? Yes, please.
The idea of the grey architecture, was it something that emerged with modern architecture, or all has been around? What are some of the challenges that have been faced through the passage?
Sorry, I didn't hear very clearly. Could you repeat it?
The idea of the grey architecture, is it something that emerged with modern architecture, or it was something around what are some of the challenges that are being faced to the root of the basket?
So your question is, what is the relationship of green architecture to modern architecture? Is it different? Is that what you mean?
Yeah, like, since when did it emerge?
Since when did green emerge?
Yeah, did it start?
Okay, that's a good question. In fact, I'm running a class here, and we were just discussing the history, the chronology, the sequence of this emergence. The idea of environmental design really started to surface in the 70s, in the 1970s, because of oil crisis. We had two very big oil crises in the 70s. And at that point, it became obvious that buildings contribute a lot to the consumption of oil. And so in many parts of the world, there was an interest in how do we reduce the consumption of buildings, but really mostly from the point of view of energy. At that time, it was quite narrow, it was quite specific. Then by the late 90s, we started to hear of a new idea called green design, which was coming in as a counterpoint to efficiency. And this idea of green was expanding the vocabulary to include not just energy, but also water and materials and land use and so on. So the conversation became wider. And this widening of the conversation in the 90s really was led by a bigger environmental movement. So if you look back in history, in the 80s and 90s, for example, Greenpeace was becoming very strong. They were becoming very vocal in terms of corporate behavior. And so this was a kind of a bigger movement that was happening globally. And within that, the building construction sector started to look at what is the role that buildings play in this discussion. So this was around the 90s. By 2000, 2010, green had become quite established as an idea. Maybe not in practice, not everybody was doing it, but almost everyone had heard of it, and almost everyone had some idea of what green was. But this definition of green was dictated by the green building movement. US Green Building Council, World Green Building Council, Singapore Green Building Council, they were defining what a green building is, and it really had to do with performance. It had to do with efficiency. Yeah. And so, as a counterpoint to that, now we are starting to see, and this is what the video is about, a bigger question of ecological thinking. Yes, you can make your building efficient, you can make the building less wasteful, but it's not enough, because you have to find a way to make your project compatible with natural systems. You have to find a way to align the design thinking of buildings and parks and neighborhoods with the way that nature works. So I'm sorry, it's a very long answer to your question, but what we're seeing is a gradual evolution of the idea from a simple idea of energy efficiency in the 70s to a bigger idea now, where many people are arguing that we cannot design without considering natural systems. Okay, I think if that's the last one, then I will thank you for your time and your patience. Maybe I see you next year.